Welcome to the 8th question in Applications to Trigonometry project. In this question, we have Tara let out 64 feet of string on her kite. Bill is standing an unknown distance away from Tara, with the kite flying in the air somewhere between them. From Tara, the angle of elevation to the kite is 70 degrees. Somehow we know that the angle formed by the kite string and the kite's line of sight to Bill is 52 degrees. How far apart are Bill and Tara to the nearest foot? Okay, so let's start solving this problem by highlighting our givens. So we are given that Tara let out 64 feet of string on her kite. We know that the angle of elevation from Tara to the kite is 70 degrees. And we know that the angle formed by the kite string and the kite's line of sight to Bill is 52 degrees. Okay? And our actual question is this right here. How far apart are Bill and Tara to the nearest foot? Okay, so let's solve this problem by first drawing our triangle. Okay, so let's make that a little bit better. We're gonna draw our triangle. And instead of labeling it our normal A, B, and C, we're gonna label it T for Tara. We're gonna label it B for Bill and K for kite. Okay, so let's look at our givens. Tara is the one with the kite. Okay, so Tara and the kite. Tara let out 64 feet of string on her kite. So we know that this length will be 64 feet. All right, that's one given done. Next given. From Tara, the angle of elevation to the kite is 70 degrees. Okay, so we have 70 degrees right here. That's her angle of elevation looking up to the kite is 70 degrees. All right, the angle formed by the kite string, which is of course this right here, of course from TK, like K, from the kite string, and the kite's line of sight to Bill is 52 degrees. We know that the line of sight, this is his line of sight, this is the kite string, so we look at the angle formed between these two, which will be this angle, and that is 52 degrees. Okay, and before we look at our question, we can just easily solve for measure of angle B, our third side of the triangle, third angle measure of the triangle, because we know that all angles in a triangle have to sum up to 180. So we know that 180 is equal to 52 plus 70 plus B, right? We don't know what B is. So we know that B is going to equal to 58, 58 degrees. Let's just make sure with our calculator. 52 plus 70, 122. Then 180 minus 122, that's 58 degrees. Okay, so 50, that's actually that. Okay, there we go. So 58 degrees. All right. And then we are asked to find how far apart are Bill and Tara to the nearest foot. So we know that we're dealing with the side length. So this is going to be our x variable. Okay, so now we don't need the word problem anymore. We can solve for this using the law of sines. So we know that the sine of 52 over x is equal to the sine of 58 over 64. Okay, so now let's simplify this problem, this equation a little bit more. We're going to have x times the sine of 58 is roughly equal to, then we put the sine of 52 times 64, which is going to be roughly 50.4327. 327. Okay. And then we can get the x by itself by dividing sine of 58 on each side, right? Because we know that these two signs, they cancel each other out, right? So we're going to be left with x is roughly equal to our number here, 50.4327 over sine of 58. Okay, so x is roughly equal to, let's see, and then remember it asks us to find it to the nearest foot. So we're going to have x is roughly equal to 59 feet. All right, this is how far Bill and Tara are away from each other to the nearest foot. Okay, that's it.